we have seen the first problem in the previous session. Let me show you that. Let me share the screen. It is a 4 by 4 determinant we have seen, and for which we have got two factors. Those two factors are giving us one AP, another one is G. Remember?
Yes, sir.
Yes, sir.
And we did with
Column.
rows and column operations, isn't it? Okay. Now, the continuation, if A is a matrix of size n by n such that A square plus A plus 2I is equal to 0, then A is non-singular, B, A is symmetric, C, det A not equal to 0, D, A inverse is equal to minus 1 by 2 into A plus I. So, if you see, that is called matrix equation. A matrix equation is given from which you have to decide the inverse of the matrix. And very, very important thing to be remembered is that A inverse exists only when it is a non-singular matrix. A inverse exists only for a non-singular matrix. What is a non-singular matrix again? If determinant of any matrix is 0, we call it as the singular matrix. If the determinant is non-zero, we call it as non-singular matrix. And the A inverse exists only when this determinant of matrix is non-zero. And you know, A inverse formula 1 upon det A into adjoint A. I hope you all remember this.
Yes, sir.
Yes, sir.
1 upon det A into adjoint A. And det A, why is it not equal to 0? You can understand from the formula itself. This det A is in the denominator. So, and one more thing, after learning the formula, what generally the students forget is the definition, because they try to remember the formula and they forget the basic definition of it. So, what is the definition of the inverse of a matrix? AB is equal to BA is equal to I implies B is equal to A inverse. This is the definition. One should not forget the definition after learning the formula. This formula is very much derived from this definition only. So AB is equal to BA is equal to I implies B is equal to A inverse is the formula. And now what we do, we will be now forming this shape. We'll be forming this shape. AB is equal to I or BA is equal to I, whatever. So what I'm doing, I'm taking up that given matrix equation, A square plus A plus 2I is equal to 0. And I'm trying to form this form AB is equal to I. So for that purpose, what I'm doing, I'm just writing it in this way. A square plus A is equal to minus 2I. So after writing this, what I'm doing, I'm taking up A common here. And this becomes A of A plus I. And because it is matrices, we should not write 1 here. Instead of 1, you have to always place identity matrix when you take something common in the matrices. So A into A plus I is equal to minus 2I, and now I want to convert this to the definition form. So the definition form is AB is equal to I. So A into A plus I want to make this I free from this factor minus 2. So what I do, I multiply both sides with minus 1 by 2. I multiply both sides with minus 1 by 2. And thereby, it can be written as A into A plus I upon minus 2. A into A plus I upon minus 2 is equal to I. So now check it out, the standard format AB is equal to I, we have reached. This is A and this is B and this is I. So AB is equal to I, and thereby A inverse is equal to minus 1 by 2 into A plus I. So this is one of the answers. A inverse is equal to minus 1 by 2 into A plus I. And because A inverse is existing and A inverse is to exist, this is to exist, obviously your determinant must also be not equal to 0. Okay, and obviously this det A not equal to 0 means it is a non-singular matrix. So what are the options here? A, C, D. I hope you understand that. If you have any doubt, please ask me. Otherwise, I'll proceed to the next problem.
No, sir. No doubts.
Can you explain how you got to that D option from the last statement?
Yeah, I have clearly shown with arrow marks there, the definition of inverse is AB is equal to I. So A written as it is, A you can see as it is, and in place of B, you have A plus I by minus 2. So, or BA is equal to I, you can write that. So when this form is there, AB is equal to BA is equal to I, then B is said to be inverse of A. So A inverse is B. A inverse is B from the definition. That's it. Any more, Dhananjay?
Sir, we could have also multiplied, pre-multiplied A inverse on both sides. So direct उनका result ही आता है.
Good. Do you understand what he's saying, Dhananjay? What Parshu is saying?
Yes, I understand.
He wants to apply A inverse, pre-multiplication of A inverse on both sides, so that this A inverse into A becomes I, and thereby it remains. And on this side, A inverse into I becomes A inverse. So you can write this D. Clear? I'm clearing it.
Yes, sir.
Moving
Hello,
to the
sir.
next question. Yes, please, Johan.
सर सेकेंड ऑप्शन कैसे चेक करेंगे?
Asymmetric, we cannot decide that. We cannot decide.
बोल नहीं सकते.
Asymmetric means A transpose is equal to A. From this relations, we are not getting any hint for that. Okay?
Okay. Thank you, sir.
Let's move on to the next question. A and B are two invertible matrices of the same order. Then adjoint of AB is equal to. So what is a basic thing you have to understand here? A and B are two invertible matrices. It is clearly given that they are invertible. Invertible means it is to be taken granted that your det A is not equal to 0 and det B also not equal to 0. These are the things to be understood first, and these can also be given in the options. Now, what is adjoint of AB? Adjoint of AB, I'd like to revise some results at this juncture. That is, whenever you are splitting them individually, the product of two matrices A, B, adjoint of A, B, then always split it from the right side. That is adjoint of B into adjoint of A. Similarly, I'd like to remind you other result, AB whole inverse. AB whole inverse is B inverse into A inverse. This is not related to this one, but and even you have inverses there. Let us check. AB whole inverse is equal to B inverse A inverse. So what all the results that are present related to splitting of the matrices when they are present under the same operation in the product like this, adjoint of AB. It is to be split from right side. If it is adjoint of ABC, then adjoint of C into adjoint of B into adjoint of A. It is ABC whole inverse is there. It is C inverse, B inverse, A inverse, like that. Similarly, in functions also, you might have remembered F circle G whole inverse is nothing but G inverse circle F inverse. Like this it is. So splitting happens always from right hand side. There are proofs for this. Of course, we don't need this because these are the objective examinations. It is to be remembered. Now, adjoint of AB is adjoint B into adjoint A, and thereby you can clearly understand the first option is correct.
E and D as well.
Similarly, the question is containing adjoint of AB, and we are nowhere at present. Let us see this later. Just to revise the concept or the formula, I have given you that. Now, you know the related formula for A inverse. Just now I wrote A inverse is equal to 1 upon det A into adjoint A. This is a formula. Now from this one, what is that can be written? Adjoint of A is equal to A inverse into det A. Never get confused with the matrix and the determinant. Determinant is always a fixed value. Determinant is always a fixed value, and A inverse happens to a matrix. So matrix is different and determinant is different. Determinant is possible only for a square matrix, and whatever the determinant you get, the final result is always a constant. So adjoint of A is equal to A inverse into det A. And similarly, you can say what will be adjoint of B. Adjoint of B is B inverse into det A. So if you replace the first result, this one, with these two, that is, I'd like to show you like this. This is, instead of adjoint A, you write A inverse into det A. Instead of adjoint B, you write B inverse into det B. Then what is that you get? B inverse det B into A inverse det A. So let us check it out. So B inverse comes first and A inverse next. So det B into det A, because they are constants, no problem, you can interchange them. So B is also right. So from this one, what is that can be concluded? B is also right. Det B, det A into B inverse, A inverse. Similarly, it can also be, now this formula is useful now. AB whole inverse is equal to B inverse, A inverse is useful now. So B inverse, A inverse is written as AB whole inverse. So what are the options here? A, B, and D. A, B, and D. Hope it is clear. So while discussing these questions, I always take it as granted that you know all the concepts, because it is advanced level explanation. So if you get any doubt in any concept or whatever the doubts you have with regards to concepts or formula or any theory, do not hesitate to ask me. I'll be explaining you that from zero level. No issues at all. So this is answer A, B, D. Any doubts here, please?
No, sir.
Sakshi? Clear? Ved?
Clear, sir.
Yeah. That's it. So let us move on to the next question. If the sum of two idempotent matrices is idempotent, then AB plus BA is equal to 0. AB is equal to BA is equal to I. AB is not equal to BA. AB is equal to BA is equal to 0. What is that I'd like to revise in this case? There are some uniform definitions for this type of matrices. When the matrix power is raised, what I mean to say by raised, you have one case, A square is equal to A. You have one more case, A square is equal to I. You have one more case, A power n is equal to 0. Because based on this question, I am revising the related theory so that the entire subject or entire theory or concepts will be revised. So A square is equal to I means it is idempotent. Matrix. Anyone, do you tell me what is A square is equal to I?
Involuntary.
So involuntary matrix. Anyone, what is A power n is equal to 0 for any natural index n? Natural index means n belongs to capital N. Anyone?
Nilpotent matrix.
Nilpotent.
In the name itself, we have nil. Nil means 0. So nilpotent matrix. So you can take the hints from the name itself. Involuntary. A square is equal to I. That is possible, you know. Why involuntary? A square is equal to I means A into A is equal to I. If you compare it with the definition of inverse, AB is equal to I implies B is equal to A inverse. So you can say, in this case, what happens? In this case, what happens? A is equal to A inverse. That is why it is said to be involuntary. And idempotent, identical. Idempotent, identical. So that is A square gives you A again. So you can remember like that. A power n equal to 0, nil potent. Nil means 0. Nil potent matrix. These are the three types of matrices which can be remembered in a uniformity with the power raised here. So let us understand now, if the sum of two idempotent matrices is idempotent, that means A square is equal to A, B square is equal to B is already given because he mentioned that they are idempotent matrices, two idempotent matrices. And again, what he mentioned, the sum of these two idempotent matrices is again idempotent. That is, A plus B whole square is again A plus B. These are the hints given here.
A and C.
So what happens now if you expand this A square plus AB plus BA plus B square. And very important, point to be remembered here is that you should not apply the formula which you know in algebra, like a plus b whole square, a square plus 2ab plus b square, should not be applied unless you know ab is equal to ba. Unless you know ab is equal to ba. If it is not mentioned in the question or in the data, you should not apply a plus b whole square formula here. But what is to be done? You have to write like this only: a square plus ab plus ba. Why? Because the multiplication happens. Don't forget, this is a basic point to be remembered, is that the a plus b whole square means you can comfortably write it as a plus b into a plus b. A into a can be written as a square plus a into b in the same order plus b into a in the same order, b into b, b square. This is correct one. This is left-hand distribution. Left-handed distributive law we apply, and you should not change the order as you like. So this is very important point to be noted. Now what is it happening? It is a square, it is a only because it is declared that it is an idempotent matrix. So instead of a square you can write a plus ab plus ba. Instead of b square, you can write b is equal to a plus b, and thereby a plus b are common on both sides. So what is that remaining? ab plus ba is equal to 0. So your option here is clear. First option is very much clear. ab plus ba is equal to 0. Then you have to see for the other options. AB is equal to BA is equal to I, and AB not equal to BA. AB plus BA is equal to 0. Let us try for the other options now, because we have already got AB plus BA is equal to 0. And you can make use of this A square equal to A and B square is equal to B. So let us try for that. AB plus BA is equal to 0. And what I do, I multiply throughout left-hand multiplication, left-hand side multiplication. I want to create a square here as a into ab is equal to minus a into ba. Okay, then instead of, you can convert this as a square b is equal to minus aba. Right. What is a square? This is a, we know. Replace a square with a. Replaced. Minus ab into a. Any hint here? Minus ab can be written as ba again here.
B.
This one. From this one, minus ba can be written as minus ab can be written as ba. So what is that I do? I replace AB here. I replace AB here with minus BA into A. So what is that I get? AB is equal to BA square. But what is A square?
A.
That's it. So AB is equal to BA is also correct.
So, but B and D, there are two options.
Cannot be B, right?
Cannot be I, right?
It cannot be I.
So
So
it will be D.
it should be 0 then, isn't it?
Yes.
It should be 0 because if you make use of these two results, this is 1, this is 2, then your AB and BA both are zeros. So your options are A and D. Your options are A and D. Let me check whether I'm missing out with any option. So according to this, we have got A and D. Let me check one moment, please. I wrote the answer at the end. Let me check it out once. No, AD correct. It is given here, AD. Okay. So that's it. So let's move on to the next question. And one more thing, it is not that easy. It is not that easy to derive all this unless you are thorough with the definitions. Unless you are thorough with the definition, it is not that easy to decide. So your options are E and in this case. Now, what are the things to be revised here? You have to revise idempotent matrix, involutory matrix, and nilpotent matrix. And we can take those three under the same category because you get them by raising the power to 2. 2 cases, idempotent and involutory, power 2 only, but nilpotent, power n, we don't know. For which n it becomes 0. Of course, n is always a natural number. Basing on those three, we have we revised those three, and whatever the data is given, we have written that here, and we expanded it, and we used a square equal to a, b square equal to b, and replaced ab plus ba is equal to 0. Now after this, because it is more than one correct answer, if it is JEE main examination, you can stop it here if the option is available. But if it is JEE advanced examination, you have to check the other things also. That is the reason why what I did, AB plus BA is equal to 0, and on both sides I multiplied with A just to create. How to get the idea? I want to make use of A square equal to A. That is the reason why I multiplied both sides with A and I replaced A square with A, and thereby AB again is replaced with minus BA. And we have got again BA square, and A square is A, AB is equal to BA we have got. But AB is equal to BA is equal to I cannot be decided, but this is equation 1, this is equation 2. If you replace BA with ABA, 2AB is equal to 0, AB becomes 0. That's it. So A and D are the option. I'm moving on to the next question, please. Okay. Next, if a square matrix A is equal to AIJ, AIJ is equal to I square minus J square is of even order, then A is a skew symmetric matrix, that A is a perfect square, A is a symmetric, and that A is equal to 0. A is neither symmetric nor skew symmetric. So A is equal to AIJ. Why I have taken this question? A is equal to AIJ given a general element given, and you must be in a position to expand this. This is the simplified form, or I must say the theoretical appearance of a matrix AIJ, and it is a square matrix given, is of even order, he is saying. And even I can take 2 by 2 also, because it is objective. Let us take it as 2 by 2. Why should we go for higher level orders? So I have taken 2 by 2, and it is mentioned that your AIJ is equal to I square minus J square. Okay, now let me write A of 2 by 2 order. A11, A12, A21, A22 is of 2 by 2 order. Now it is clear that 1 square minus 1 square, 0. It is 1 square minus, and don't forget that order is to be substituted here. I'm substituting instead of I, 1, instead of J, 2. So 1 minus 4 is minus 3. Similarly, 4 minus 1 is 3. And it is 4 minus 4, 0. So the diagonal is 0. The diagonal elements are zeros. So what is that to be understood? It is very clear that this is minus 3, this is plus 3. If you find out the transpose of this matrix, A transpose is equal to 0 minus 3. And I hope everyone knows the transpose. It is row becomes column and column becomes row. So 0 minus 3, 3 0. And it is clear that this becomes minus A. So A transpose is equal to A, symmetric matrix, and A transpose is equal to minus A is skew symmetric matrix. If you forget them, these are to be remembered. So it is confirmed that A is a skew symmetric matrix, and hence option A is correct.
So A and B.
And similarly, if you see
B is also correct.
determinant of A, if you see determinant of A is here, det A. And det A is equal to 0 plus 9. It is 3 square. It is a perfect square. It is a perfect square, and hence you can say that det A is a perfect square. And A is symmetric, obviously not. A is neither symmetric nor skew symmetric. It's wrong. So what are the options here? A and B. Clear?
Yes, sir.
That's good. Now, anyone please? Any doubts? I'm moving on to the next question.
No doubt, sir.
Yes. A square matrix A with elements from the set of real numbers is said to be orthogonal if A transpose is equal to A inverse. If A is orthogonal matrix, then A transpose is orthogonal, A inverse is orthogonal, adjoint of A is equal to A transpose, that should be transpose only. Maybe the operator's mistake, like it should be mentioned as A dash. A dash is nothing but the transpose. And det of A inverse is equal to 1. These are the options given. Okay. Daksh is there. Daksh is needed. Daksh is there in advance or not?
Yes,
He's
sir.
there,
Yes,
but
sir.
it seems he has no mic.
सर दक्ष के पास माइक नहीं है, प्रथमेश जैसा हालत होगा.
Oh, good boys. Both are good boys. Aha. Right. Jahan,
Yes, sir.
एक बार question पढ़ो. Read the question once, please.
A square
Write the
matrix
data and you tell me the
A.
data.
A is a square matrix with elements from the set of real numbers is said to be orthogonal if A transpose is equal to A inverse. If A is orthogonal matrix, then now I have to say the data.
Okay. A transpose is equal to A inverse is given by him. But what is the definition of orthogonal matrix? What is the definition of orthogonal matrix? A transpose is equal to A transpose A is equal to I is the definition of orthogonal matrix. Do you remember that?
Yes.
Yes.
So here, can we go by an example?
For A transpose into A is equal to I, you need the example.
No, I'm saying we solve the sum using an example, like for the orthogonal part.
Yeah, then we have to create such a matrix which is orthogonal, and of course he gave another condition also, A transpose is equal to A inverse. Let us find that, but before that let us decide. So A transpose is orthogonal, he's saying. First option,
Yes.
if A transpose is to be orthogonal, and if you see the definition of inverse, if you see the definition of inverse is AB is equal to BA is equal to I. Okay? AB is equal to BA is equal to I. Now, if you compare it with the orthogonal definition, obviously, in place of B, you have A transpose, and it is quite applicable. It's quite applicable. In place of B, you have A transpose. Correct or not? So what is that can be concluded here from this one? From this one, A inverse is equal to A transpose is given, or otherwise you can write in the reverse order also. Like what? Like what? You can write it as A transpose whole inverse. A transpose whole inverse is equal to A. It can be written like this also. A transpose whole inverse is equal to A. And A transpose is orthogonal, he is saying. So to decide orthogonality, what is that to be understood? A into A transpose must be I. If you multiply the matrix A with its transpose, then you must get I, identity matrix. So what the first option is, he needs A transpose is orthogonal in the first option. A transpose is orthogonal. A transpose is orthogonal means the same definition, obviously. Set of real numbers, A is an orthogonal matrix he has given. Obviously, A transpose also becomes orthogonal. When A is orthogonal, A transpose is also orthogonal. No, do you understand what I'm saying? So A is correct.
Yes, sir. Yes.
A is correct, but you have to prove that second option, according to second option, whether it is A inverse is orthogonal or not is to be proved. So if A inverse is orthogonal or not, if it is to be proved, so option A is correct here. Okay. From this one itself, we can say option A is correct. So next one is A inverse is orthogonal means what is to be done here? A inverse, I'm talking about option B here, into A inverse whole transpose must be I. Whether it is possible or not, you have to check. You have to check.
It is possible.
Take whole inverse here. Take whole inverse on both sides. what happens? A inverse whole inverse. I write it here. A inverse whole inverse is what? A. Correct, no? A inverse whole inverse is A. So, A transpose whole inverse is equal to A. And obviously, taking inverse on both sides, A transpose is equal to A inverse. That is given very much. From that only we wrote this. So what happens? Instead of A inverse, you can write A transpose, whole transpose. Obviously, what happens? A inverse is also orthogonal. Do you understand what I'm saying here? Please.
Yes.
So A inverse is equal to, instead of A inverse, you write A transpose. Just a moment. What I'm doing. A inverse into, I need A inverse whole transpose. What is A inverse whole transpose, please? A is equal to I, proved. In fact, this is to be proved. What I wrote is to be proved. To get B option correct. To get B option correct, this is to be proved, please. To be proved. So what I did, I have taken this and I proved that this is equal to I.
Sir, ABC all are correct.
ABC or D also. Adjoint of A is equal to A transpose. Adjoint of A is equal to A transpose. Let us see that. Now it is given that A transpose is equal to A inverse. Option C I'm talking about. Option C. Adjoint of A. What I do, I'll be writing this. A inverse is equal to A transpose like this. A inverse formula, everyone knows that it is, we need adjoint A, no? 1 by det A into adjoint A is equal to A transpose. Okay? So 1 by det A into adjoint A is equal to A transpose. So what should be adjoint A then? Adjoint A is det A into A transpose, please. Is it visible, everyone? The screen, please.
Yes, sir.
Now here, according to this, adjoint A is equal to A transpose happens only when det A is equal to 1. Det A is equal to 1. Is it possible that det A is 1? Because
Yes, sir. It is possible.
how?
Not all the time.
Pardon me?
Not all the time.
Because if you take determinant here for this one, det of A transpose is equal to det I. Det I is 1 and det of AB is det A into det B is equal to 1. So det of A is equal to det of A transpose. We are learning the properties also simultaneously and we are reminding the concepts or the formulae. Det of A and det of A transpose both are same. So this becomes det A into det A. Det A is 1 plus or minus 1, you can say. Det A is plus or minus 1. And hence
Sir, नहीं आता.
this is 1 only. Okay, this is 1 only. So adjoint A is equal to A transpose is correct. And what about D?
D आता है sir.
Huh. Det of A inverse is equal to 1.
Sir C नहीं आता है.
Why not plus
It
or
will be true
minus C?
for
Yeah.
डिटर्मिनेंट कैसे लिए
it cannot be true for all values of all matrices A.
You are talking about this one?
लेफ्ट हैंड साइड
You are talking about this?
Yes sir.
क्योंकि सर सिर्फ ए का उन्होंने डिटर्मिनेंट है 80 तो मैट्रिक्स ही है यहाँ पे दोनों का हो गया.
No, what I'm writing, just see this. Det A into det of A transpose, both are equal, no? Do you know that?
Yes
I
sir.
can write it as det A whole square is equal to 1.
Yes.
Then what is det A?
1.
Plus or minus 1.
Oh, अच्छा समझा. Yes. हाँ, C is correct.
सर पर मैट्रिक्स मल्टीप्लिकेशन का डिटर्मिनेंट और डिटर्मिनेंट का मल्टीप्लिकेशन सेम कैसे होगा?
Det of AB is equal to det A into det B.
But can we do the second step? AAT का determinant will be separated like that in the next step.
नहीं हो सकता ना.
Which one are you talking about?
The
First,
step after that, when you separated the matrices and taken the determinants product like that separately.
That means you are not aware of this formula or you might have forgotten. Det of AB can be written as det A into det B. Do you know this or not? Because both are constants.
Yes sir.
That's what it is. I did.
Okay, sir.
Why where it is not possible?
ये फॉर्मूला नहीं पता लगा.
It's correct. Because it is not matrix multiplication. That's what I said in the beginning. It is determinant. It's a fixed value. If it is matrices multiplication, it's not possible. AB need not be equal to BA unless it is defined. Do you understand what I'm saying?
Yes sir.
If A and B are square matrices of the same order, if A and B are of the same order, square matrices of the same order, then the order of AB and order of BA will be same. But it is not. It need not be that AB is equal to BA. So it is to be mentioned. That is the reason why we have not taken A plus B whole square. We have not taken A plus B whole square as A square plus 2AB plus B square, but we have taken it as A square plus AB plus BA plus B square. But in the determinants, it is different. Det of AB is equal to det A into det B. Clear? So what are the options here? And what about D here? Det of A inverse is equal to 1.
So A inverse is A
Obviously it
transpose.
happens. Obviously it happens because det A is equal to, we got plus or minus 1 now. Det A we have taken plus or minus 1. When you take det on both sides of this, are you with me?
Yes sir.
Det of A transpose is equal to det of A inverse. What is det of A transpose is nothing but det A only. Are you with me?
Yes
Det
sir.
of A transpose is same as det A. So det of A inverse is equal to det A. But what is det A? 1. So det of A inverse is also 1. So what are the options here? A, B, D. But what I doubt here, we are getting det A is equal to plus or minus 1 here. Two values are there for det A. If he has taken only plus 1, this is right. And if he has taken only plus value, this is also right. But if we take minus also no, you will get adjoint A is equal to minus A transpose. Det of A inverse is equal to minus 1. That means two more answers you can get. But B and D, C and D are also correct. Are you with me what I'm saying?
Yes sir.
Yeah, let me check the answer anyway. Just a moment. AB are given. Just see that. AB are given. Only AB are given. The reason I mentioned already. That means he has not taken only plus, but if it is to be clearly given, we must consider plus or minus there. If plus or minus is given, then it is correct. I hope you understand what I'm saying.
Yes, sir.
I mentioned that in the beginning itself. So, what are the options here? A and B only. A and B only. Okay? Clear? I'm moving to the next question, please.
Yes, sir.
And this can be done by you easily. Anyway, do you remember how to find out a joint of a matrix or not?
So
Yes, sir.
इसको simplify कर सकते हैं. R2 R1 minus R2 से तो 1 0 0 हो जाएगा ऊपर का रो.
ठीक है, करो ना. A joint.
No, we would actually find cofactors and then put alternate minus signs on each.
Yeah, that's what it is. When did you
And then take the transpose.
when did you finish the matrices and determinants main class?
So
It was
2019
like a year ago.
Means कब हुआ था?
2019 November.
Oh,
Matrices.
almost a year ago.
हाँ
You said
sir.
that about sequences and series.
तो सीक्वेंस सीरीज के भी पहले हुआ था.
वो भी तभी हुआ था क्या?
हाँ सर.
उसके बाद ये हुआ.
So both were taught by different teachers. तो हम लोग को सीक्वेंसेस सीरीज पहले हो गया था
ठीक है.
और फिर उसके बाद नवंबर के टाइम पे ये हुआ.
And one more thing, adjoint of adjoint A, you have a formula that of A whole power n minus 1 whole square into A. Do you know this formula or not?
Yeah, yes.
Yes, sir.
So that of adjoint of adjoint A, this one, if you take the determinant, just a moment, if you take the determinant that of adjoint A is det A power n minus 1 whole square. You can have one more formula, that of adjoint A. 3 adjoints will be there. Then it will be det A power n minus 1 whole square. Okay? Come on. Can you do that? Please help me out, anyone. Even if you don't know also, you can find it out faster. Please follow me first. Stop writing. If you are doing that, of course, it is all virtual. Whether you are doing it or sleeping or listening or everything is virtual.
ये आता है.
You'll get A. You must get A. That's what I'll show you. Even after doing this, because why I'm doing the method will also be revised. That is the reason why I'm doing it. And after we derive this, we will apply the formula also, so that the formula will also be revised. What Parsh was saying about the signs, first of all, before writing adjoint of any matrix, write the transpose first. This is transpose. Of what? Transpose of that matrix whose elements are replaced with their corresponding cofactors. Transpose of that matrix whose elements are replaced with their corresponding cofactors. So, these are the signs of cofactors. And cofactor is equal to minor when it is plus sign, and cofactor is equal to minor in magnitude when there is minus. So while working, we take in the working rule what we do to solve this easily, or to work out this easily, we write plus minus alternatively. Now I'm writing the minor of 3 or cofactor of 3, because I should not say now as cofactor because I have already placed the signs here. And I'd like to remind you one thing here. If Aij is the matrix, then Cij, that is cofactor of element Aij, is nothing but minus 1 whole power I plus j into Mij. What is Mij? Minor. What is Cij? Cofactor. Okay. Now what is minor again? What is minor again? It is the determinant of that matrix which is got by eliminating that row and that column in which that element is present. I repeat the definition. The minor of an element is the determinant of that matrix which is got by eliminating that row and that column in which that element is present. For example, if you want to find out the determinant of the minor of 1, for example, then you have to eliminate that row and that column in which that element is present. Remove this, and find the determinant for this. So cofactor minor of this element is got by eliminating that row and that column in which that element is present. Similarly, if you want the cofactor, or let me say minor of -3, if you want to understand the minor of -3, which is present in the second row, second column, then eliminate that row and that column in which that element is present. Then the minor is got by determinant of 3, 4, 0, 1. So 3 into 1 minus 0. 3 minus 0. This I'd like to revise. I hope everyone knows this. If you know this,
Yes.
it is waste of time for me to explain. If someone is not knowing, that will be useful for them. I hope everyone knows this. And you must know. If you do not remember, you must revise that. That's a basic thing while finding the adjoint of any matrix. First of all, write the transpose and write the signs with plus and minus in the alternative order, and then replace the element with its corresponding cofactor. Replace the element with its corresponding cofactor. I'm replacing it now. That is first one.
So
-3 plus 4, 1. Someone is saying?
So for the formula in blue, n is the order of the matrix, right?
Yeah. N is order of the matrix. Correct. For -3, it is 2. For 4, it is -2. For 2, it is -3 plus 4. And for -3, it is 3. For 4, it is -3. That's it. It becomes +3. And for 0, it is -12 plus 12. For -1, it is 12 minus 8. And for 1, it is -9 plus 6. This is what you get. Write the transpose of it. Write the transpose of it. Just why I have taken, I can directly make use of the formula adjoint of adjoint A is equal to det A power n minus 1 whole square into A. But what I did, I'm revising this, how to find out adjoint A, because it's long back it is finished. I'm teaching you how to find out the determinant, adjoint A, okay? So, comma, let me write the transpose of this matrix.
Sir, in the last element, it should be only -3, not -3.
Yes, you're right. You're right. It is plus only, no?
Yes.
And one more thing you can always understand, in the diamond form, minus signs will be there. In the diamond form, minus signs will be there. So let me write the transpose 1, -2, -2. And -1, 3, 3. 0, -4, -3. Okay. Now you can try for adjoint of adjoint A, please. Come on, do that. Anyone, do you help me out in writing that? I'm not doing that. You do it now. Adjoint of adjoint A. You do it now. Adjoint of adjoint A, because adjoint A is now written there. Let me write that adjoint of A as some B for your convenience. Now I need adjoint of B. Adjoint of B, write it first, the transpose, otherwise you will forget. Otherwise you will forget, please. Whenever you find the adjoint, write
Sir, आगे adjoint.
transpose. Tell me that, Srivardan now. Straight answer,
3 minus 3.
straight answer बताएंगे नहीं तो transpose बताएंगे.
सर डायरेक्ट adjoint बताऊंगा.
ठीक है, ये तो लिखना पड़ता है. You have to write that whole transpose, and after that only you'll get the answer. Otherwise you'll forget. Don't attempt the error by forgetting transpose. But I'm writing, because I taught this. I'm writing this directly. Come on, tell me. Let us believe Srivardan. Come on, tell me the answer.
3 minus 3, 4.
Yes.
2 minus 3, 4. And 0 minus 1, 1.
Now, let us understand what is. Let us understand what is det A. Let us write that directly. What is det A? Here it is clear. These are the cofactors. These are the cofactors of the corresponding elements. So you can multiply 3 into 1 minus 3 into minus 2 plus 4 into minus 2. What should it be? 9 minus 8, 1. That is 1. So you got adjoint of adjoint B, same, no? Same matrix you got. It is here. So first option is correct. Second option, det of adjoint A, again 1 only.
Yes.
B and C both.
And det of adjoint A is also, I think, the same matrix. Huh? Just check it out. Det of adjoint A. Det of adjoint A, and I'd like to remind you this formulae. Det of adjoint A is equal to det A power n minus 1, please. If you forget, this is frequently used one. This is frequently used one in the objectives. You don't find the time to do all this in the objective examinations. That is why you have to make use of this. And det A we have already got it to be 1. So det of adjoint A is also 1. So what are the answers now? A, B, and C. A, B, and C. Clear? Okay. Let's move on to the next question. Any questions, please?
Also.
And this B can be straight away answered with data only. And Dhananjay was asking about the N here. N is nothing but the order of the matrix. Order of the matrix is 3 by 3, and hence N is equal to 3. Okay. That's what it is. Now let us go through the next question. If P is a non-singular matrix and AB are two matrices such that B is equal to P inverse into A into P. Priyanshi is there in the class? Priyanshi? Let me check. Because continuously teaching, she might have slept. But I think she's not in the class. Otherwise, she responds faster.
So she is present.
प्रियांशी नाम नहीं दिख रहा है इधर. Yes, नाम नहीं दिख रहा है. P दिख रहा है. P पार्श का है ना. प्रियांशी not seen. Daksha is mute. Divya Mohanty.
Yes, sir.
बोलो बेटा एक बार.
P is a non-singular matrix and
Just a moment,
AB
beta.
are
Just a
two
moment.
matrices such that B is equal to
Just
P
a
inverse
moment.
of AP. Then the true statements among the following are.
हाँ, मैं क्या बोल रहा हूँ? When you are reading it, then itself you have to write the data. That's what I mean. Come on, tell me, if P is a non-singular matrix, what is the immediate condition to be written? Det P not equal to 0.
Not equal to.
Okay, that means P inverse exists. Okay, come on. A, B are two matrices such that. बोलो बेटा, दिव्या. B is equal to P inverse into AP, है ना? True statement among the following are. Come on, tell me that, please. You can do that.
3 multiply by matrix P on both sides.
With matrix
P.
Okay. Then you'll get PB is equal to AP. Good. Come on, follow that, please. Follow that. A is invertible if and only if B is invertible. B power n is equal to. You have to always go through the options. Unlike JEE main examination, you have single correct option there. That is where you can straight away solve the problem. But here, you have to go through the options to decide. P inverse into A. Now, what he's saying is, let us multiply both sides with P. then what happens? PB is equal to P inverse into AP. Then PB is equal to PP inverse is I into AP. But whenever identity matrix is multiplied by any other matrix, you will get the same matrix. That is the reason why it is said to be identity. So I into A becomes A only. PB is equal to AP we have got. Now from this one you have to decide.
Sir, but we have to multiply by B, right? B taken n times. So we will get P inverse AP into P inverse AP. So P into P inverse will be I, and then the power of A will be raised.
That's okay. Option B is correct only. Option B is correct only. I'm just checking for A there. A. Yeah. Now, after this, let us take det on both sides. With det of PB is equal to det of AP. वेद का नाम क्यों लिया मैं? पार्श्व का भी नाम लेना है. क्यों लिया बेटा? Why I have taken your name here? Det of PB is nothing but det P into det B. You can split it comfortably. And det A into det B. Correct now? But he has given that det P is not equal to 0. He has given that det P is not equal to 0. That's what we have written in the beginning. You can take det P common here. And or otherwise, because det P is known to be not equal to 0, det B is known to be not equal to 0, you can comfortably cancel off this. Then what is the result you get there? Det A is equal to det B. Are you there, everyone? Please respond. Det B is equal to det B. Det A we have got. Now, what is the first option given? If A is invertible, if and only B is invertible, because both are equal. Both are equal. If one is invertible, obviously other one is also invertible. Invertible means what should be the condition, please? What should be the condition for inversion? You must have a non-singular
Determinant
matrix.
not
You must have a non-singular matrix. That is, determinant is not equal to 0. Correct now? So first option correct or not? You tell me, please.
It's correct.
So yes, sir. C should be automatically incorrect.
Which one? Achha, we need the true statements among the following. Yeah. Then this
So D
B is automatically correct because you can raise the power, because if you multiply both sides with B, P inverse into P will be same, whatever is there. P inverse whole square. So B is also correct.
Sir, and C and D are also true.
How is
D
B
cannot
correct?
be. D cannot be.
So D is incorrect.
No, B, D not, sir. C, sorry. D not, C. Only C.
D cannot be said, beta. D cannot be said because we have got it. Det A is equal to det B, we got it, but we don't have any hint whether they are equal to 0 or not. So that is the reason why we said A correct. If A is correct, D should not be. If D is correct, A will not be.
हाँ सर, वो थोड़ा confusion हो गया, पर C correct है सर.
C is also correct. You can, because A and B are two matrices, you can both sides lambda I will not make any difference there. So B minus lambda I and A minus lambda I. That is B replaced with B minus lambda I and A replaced with A minus lambda I. So that is also correct. So three options are there. Just any doubts, please, in that? Okay. I'm moving on to the next one, please. But anyway, let me check the answer once. Sometimes we may go wrong. ABC correct. Correct. So whatever the settings I did to prepare the document is working out perfectly. Unless I open the answer, it is not shown. Great. I must be proud of myself. Do you accept this or not?
Yes, sir. Yes, sir.
Thank you. Right. बहुत मेहनत करना पड़ रहा है बेटा ये सब बनाने के लिए. ऐसा है कि फिजिकल क्लासरूम में क्या हो रहा है, हमने वो मार्कर लेते हैं, बोर्ड पे जाते हैं, जो है मन में दिल में वो बोल देते हैं. लेकिन अभी कितना काम कर रहा है यार, बता नहीं सकते. वो तो एक प्रेजेंटेशन बनाने के लिए बहुत टाइम लग रहा है यार. ये प्रॉब्लम्स को चुनना, उसके बाद आप समझ रहे हैं ना मैं क्या कर रहा हूँ. इधर एक एक स्क्रीनशॉट लेके इसको पेस्ट कर रहा हूँ. उसके साथ साथ ये इमेज देख रहे हैं ना आप उधर बाजू में, वो इमेजेस के लिए क्या कर रहा हूँ पता है, वो यूनिफॉर्मिटी के लिए जो मैं स्क्रीनशॉट्स लिया, उसके बाद उसको गैदर किया, उसमें एक इमेज स्लाइड शो बनाया. वो जो स्क्रीनशॉट लेते हैं वो तो नॉन यूनिफॉर्म रहेगा, तो इसलिए उसका साइज चेंज करना पड़ रहा है. उसका साइज 1280 into 720 पिक्सल्स में कन्वर्ट कर रहे हैं. तो वो सब यूनिफॉर्मिटी बना के आपको दिखाने के लिए बहुत काम है यार.
Thank you, sir.
Thank you, sir.
मैं जब खुश होऊंगा, ये टारगेट जो मेरा है, आप तो सक्सेसफुल हो गया तो मेरा जिंदगी सफल हो जाता है. That's what my task and target. You have to perform. That's the thing. Let's move on to the next question. Hamida. An is n by n matrix in which diagonal elements are 1, 2, 3, so on n. A11 is equal to 1, A22 is equal to 2, A33 is equal to 3, Ai is equal to 1, Ann is equal to n. All the diagonal elements are declared. What I do, I'll just give you what is A5 so that everything will be clear to you. I'll give you A5 because A5 is needed here. Okay, Rajat?
Sir, its determinant will be 5 factorial, na?
हाँ, correct.
हाँ, VK sir ने बताया था.
हाँ, very good. Rajat, A5 I'm writing here.
Yes, sir.
A5 is A11, A22, A33, A44, A55.
तो factorial आ जाएगा.
He's saying N is an n by n matrix in which diagonal elements are 1, 2, 3, so on n. And all other elements are equal to n. You should not forget that. All elements are equal to n. वो प्रियांशी क्लास में देख रहा है आप लोगों को?
हाँ सर, क्लास में है।
मेरे को इधर नाम नहीं आ रहा यार। है, आपको दिख रहा है धनंजय?
और वो पार्टिसिपेंट्स के लिस्ट में जाके करना पड़ेगा।
भी देख रहा हूँ यार।
अभी आई।
क्या बेटा साक्षी?
पहले नहीं था, अभी है।
अभी है, मतलब बीच में गई रे बाहर। क्या है प्रियांशी? यस सर बोलेगी, देखो अभी नहीं बोल रहे, हालत बेकार है। 5 Rachit, what he has given,
Yes,
he said that all the remaining elements are equal to n. We are taking a5, so all the remaining elements become 5. So this is 5, 5, 5, 5. Okay, so this is 5. This is 5, 5, 5, and 5. And this one is 4, 5. Like this, the matrix is declared. This is what the matrix gives. I hope you understand what I wrote there.
Yes.
Now it is clear, if you find out the determinant, obviously, because all the remaining elements are 5, you will get it as the product of the diagonals. Det of A5 is equal to, det of A5 is equal to, you will get the product of all the diagonal elements. You can treat them as zeros, you can make them zeros, that's what I mean to say. How? How? Make use of first row. Operate R2 minus R1, R2 minus 5R1, R2 minus 5R1, and R3 minus, or otherwise you can understand like this. You write it as, this is R5, R5 minus R4, R5 minus R4, R4 minus R3, R3 minus R2, like that. You will get all the elements, remaining elements in the operation 0. This is 1 into 3, 2 into 3 into 4 into 5. You will get the answer, that is 120, 5 factorial. So C is correct. What about the rest of the answers? Anyone in the class?
Sir, B भी correct होगा.
A is singular for all n is wrong because you will get some other value other than 0. A is non-singular for all n, B correct. That of n is 0 is wrong. So what are the options here? B and C. Any doubts, please?
No, sir.
Oh, it is 9:40. What is the time for the next class, please?
Our class is at 12.
12 o'clock. 12 o'clock.
हमारा लेक्चर 12 बजे से
12 बजे का।
हाँ.
Right. That's what it is. So options B and C are correct. I hope you do not have any doubt because I wrote the entire matrix there.
No
Yeah.
doubt.
Next one, please. This is also, let us close with this one. Next one. Just observation. Observation is very much needed there. Anyone, please, do you tell me the derivative of first column?
2x plus 4.
2x.
Yes, 2x plus 4.
And then 0.
Into 2 into 0.
सर पर 3 पार्ट्स में डेरिवेटिव करना पड़ेगा ना,
We'll have to
एक
take
पहले
separate
रो का, फिर
derivative.
दूसरे रो का, फिर तीसरे रो का.
But why do we need to take derivative?
X will be eliminated.
No, just we are checking out if you take the derivative, if the determinant value is independent of x. If the determinant value is independent of x, that means if it is a constant, its derivative obviously becomes 0. So we are trying whether delta x is 0 or not. If delta x, if you get 0, then you can confirmably say that delta dash x is 0, then you can confirmably say that delta x is a constant. Are you with me what I'm saying?
Yes, sir. So B and C should be correct then. Because if it's a constant, then it is independent of any powers of x.
You're right. But let me revise once the derivative of the determinant what Srivardhan was saying. It goes like this. It goes like this. Let me take 3 elements in the first row as A of x, B of x, C of x. And H of x, G of x, F of x. F of x, G of x, H of x, and L of x, M of x, N of x. If you want to find out the derivative of the determinant, generally you can simplify the determinant, you can find out the determinant. There is no problem in that one, in doing that, but it goes lengthy. It goes lengthy by finding the determinant and finding its derivative can also be done. There is no doubt in that one, but what is the other method of doing it? Sometimes what happens now, one row becomes completely constant or 2 rows becomes completely constant. Then in that case, it is very much useful. So let us see, if you want to find out the derivative of the determinant, then what is to be done? Just write the derivative of the first row, A dash of x, B dash of x, C dash of x. Okay, and the rest of the rows as it is. This is what Srivardhan was saying.
Yes, sir. Then plus second row derivative
I'm
plus
reminding you this concept. Yeah, plus. I'm not writing the entire matrix now. I'm just giving you the hint. The rest of the 2 should be written as it is. Similarly, here also R1 remains the same, R2 remains the same, but you have to write the derivative of the second row, F dash x, G dash x, H dash x. Plus. You tell me please.
R1, R2, L dash x, M dash x, N dash.
L dash x, M dash x, N dash. Advantage is whenever any row or column is constant, then the entire derivative becomes 0. No, that is the advantage. That is the advantage. You have to understand that. This is what the derivative of the determinant, please. Derivative of the determinant. Now let us apply the same. I think I revised this concept. Everyone remember?
Yes.
First row derivatives, R2, R3 same. Second row derivative, R1, R3 same. Third row derivative, R1, R2 same. Okay.
तो अभी हम लोग कॉलम वाइज जाएंगे, क्योंकि कॉलम वाइज गए तो फिर 2x plus 4 2x plus 4 और वो आ
That's what
जाता
I'm
है,
saying. That's what I'm saying.
C1 C2 आ जाता तो
You
0.
can even take column wise also. The same can be applied column wise also, because det of A is equal to det of A transpose. Det of A is equal to det of A transpose. The same property can be applied even for columns also. Why? Someone asked me, so who asked this? Parsha. Why should we take derivative? He asked, no. So I got the idea from this one. Derivatives are same.
Yes.
So you need not have to write the first one because that becomes 0. That observation is very much needed for you while answering the questions. Then I needed to go for the further step for this because it becomes 0. Similarly, if you find out the derivative of third column, obviously that is also 0. Okay. Then if you find out the derivative for this second column, 2, 4, 16 is there. And if you take 2 common, are you with me?
Yes,
That
sir.
is also 0. Just check it out. First column I am writing as it is. Column 1 as it is. I am mentioning it as C1 only. I am not writing that. C1. And come on, tell me the derivative of second column, please. 2,
4 and
4, 16, 13, 26, 104 as it is.
C3 आ जाता है.
But if you take 2 common here, 1 to 8. If you take 2 common here, 1 to 8.
13 common there.
One, 2, 8. Take 3 common.
13.
Yeah, you understand that I need not have to tell you that.
Yes.
Take 2 common. Consider. Take 13 common in C3. So obviously, this is 1, 2, 8. This is 1, 2, 8. So it is also 0. Therefore, delta dash x is 0 means
Delta x is a constant.
implies delta of x is a constant. Comfortably, that's a good question. He has given a second column in such a way that it is the derivative of the first column. That is the reason why you must have good observation while reading the question. Delta x is a constant means no x terms will be present. No x terms will be present. So what happens? Only constant remains. So A is equal to B is equal to C is equal to 0. And thereby you can check the options. A is not 3, A is equal to 0, C is equal to 0, B is also 0. So options are B and C. Clear, please?
Yes, sir.
Yeah.
रो ऑपरेशन से भी कर सकते हैं ना? ओ,
समझा नहीं वेद?
रो ऑपरेशन से भी कर सकते
कर
हैं
सकते
ना, क्योंकि
कर सकते बेटा,
x के कोएफिशिएंट और x स्क्वायर के रेशो में है।
कर सकते हैं, लेकिन ये आसान हो जाता है।
सर अगर ये नॉन जीरो आता तो क्या करते?
So what you have to do then, if you want the value of D now, put x equal to 0. You'll get D.
But sir,
Put
if
x equal to 1.
A
Put
is
x equal to
non-zero.
1. Then you'll get one more equation. Like that you have to do. By giving values to x, you have to get the values of A, B, C.
And for sir, AX cube.
I'll take such a question which you are asking. I'll be discussing that further. Okay?
Yes, sir. Thank you.
See you all in the next session. Have a good day.
Thank you, sir. Good day.
Thank you.